So now that this first part is complete, I'm going to turn my attention towards this K part and the code words part. So, since the distance 1 code is basically just counting in binary, I know I can do this with 4 code words with just 2 bits. So I'll get rid of this, and I'm just going to go through the normal binary. So we're going to have 0, 1, 1, 0, 1, 1, and I have my code. Then, for the next distance, as we kind of talked about in theory, that basically if I add a parity bit, I'm adding a distance of 1 to the code by only adding 1 more bit. So here, I'm going to increase that to 3, add a 0. I'm going to make this even parity, because that's even, so I'm going to have 0, 1, 1, 1, 0, 1, and this is going to have to be 1, 1, 0. And so we got distance 2, distance 2, distance 2, and distance 2, and distance 2, and distance 2. Good. And so now, let's look at distance 3. Well, I could try 4 bits, but if I have to have 3 1s, then essentially I can't have 2 code words with 3 1s that are still distance 3 apart, because there can only be 2 bits that are different. So I'm going to have to go up to at least 5. So let's try 5 first and see what happens. So I've got 0, 0, 0, and I'm going to have 3 1s. So 2 1s, 0s followed by 3 1s. And I know if I flip this, it'll still be distance 3 from there, so I'll keep this one over here. And so let's see if I can find a pattern that works that's similar to this 1, 0, 1 idea. So if I put 2 1s here, a 0 here, and 2 1s here, that's going to be distance 3, and since these are just reflections, it'll still be distance 3 from both of those, so I'll do 1, 1, 0, 1, 1. Now let's go up to distance 6. So I'm going to need 4 1s, and I'll still have 2 zeros, so if I think I can still get distance 4 out of this, so let's try it. 6, so 1, 2, 3, 4, 5, 6. And we'll have to have 2 zeros and 4 1s. And I want to do the reflection, so 1, 2, 3, 4, 0, 0. So the 2 zeros and 2 1s are distance 4 from there, so that's good. And now we're going to need, so that's going to be distance 2 from there, and then I'm going to want 2 zeros here to make distance 4 from this code word, and then I'm going to want to make sure I still have 4 1s. And so by the reflection symmetry thing, I know that it's also distance 4 from there. So that's code word's good. And now for this one, 7. Well, kind of by similar reasoning as before with the 5, why I didn't use 4 and used 5 instead, I think I can justify saying 8 here. So 1, 2, 3, 4, 5, 6, 7, 2, 4, 6, 8. Sorry, there we go, 8. And so I'll start off with 3 zeros, and I'll need at least 5 1s. 5. And I'm going to reflect this. 1, 2, 3, 4, 5. 1, 2, 3. And then keep this similar pattern, so I'm going to put 3 1s to start. I'm going to need 2 zeros. And then I'll keep these ones the same, and by reflection this will be the same. Distance 5 from here, distance 5 from there, and distance 6 from that one. So that completes my code. So I've now completed all 5 codes, and now I need to answer part 2. So part 2 says, give an expression for the number of errors that the code can detect. So basically that's just going to be based off distance, d, and so we just see 1, 2, 1, 2, 3, 2, 4, 3, 5, 4. That's just going to be d minus 1. And now I've got to give an expression for the number of errors the code can correct. So let's graph that. We'll do that with a short little graph. And we will have distance here, D. 1, 2, 3, 4, 5, 6. And number of errors correctable. So it's 1, 2, 3. And so we're going to have at distance 1, 0. At distance 2, 0. Sorry, let me put correctable. Along this axis, and then so 3 is 1, 4 is 1, 5 is 2, and kind of by similar reasoning what we did before, I'm going to be able to say that 6 is 2. So we find here, essentially we have a function with slope 1/2, and we have another line with also slope 1/2. So essentially, if I try to graph this line, which is basically going to be, it's going to have 1/2 d, and then this intercept is going to be negative 1/2. So minus 1/2 is this line here. And there's actually a very powerful nonlinear function that we can use called the floor function, which basically converts any fraction into, or rounds down essentially, any fraction. So like if I have 1/2, the floor is equal to 1. So basically I can say just this is at 1/2 and I want it to go down to 1, I'll just take the floor. So the answer to this question is just going to be the floor of this, which I can simplify to be d minus 1 over 2, the floor. And hopefully that wasn't too much hand waving, and if you have any questions, feel free to ask them.